Okay, so this homework starts with a little bit of a discussion about special triangles. So let's see if we can fix these fill in the blank questions. So I've drawn the two special triangles that we learned about in class. And then we're trying to fill in the blanks here, right? So the hypotenuse is always something than the shortest side. So we're looking for what you have to do to the shortest side to turn it into the hypotenuse. So what do you have to do to turn 1/2 into 1? You have to multiply it by 2. So the hypotenuse is always 2 times the shortest side. And the side opposite the 60-degree angle is always, so what's the relationship between the shortest side and the side opposite the 60-degree angle? You can see to turn 1/2 into the square root of 3 over 2, you'd have to multiply both things by the square root of 3. All right, what about the 45, 45, 90 triangle? The legs are always blank and the hypotenuse is always blank the legs. The legs are always the same, okay, because this angle is the same as that angle. The two sides opposite them have to be the same as well. So the two legs are always equal. Okay, now, and the hypotenuse is always blank the legs. Okay, so what do you have to do? How would you have to multiply this by to turn it into that? Well, let's just look. I'm going to try guess and check here. So if you do the square root of 2 over 2, and I'm going to try to multiply it by something and get 1. So I'm just going to put the square root of 2 here, and let's just see what happens, okay? So these two square roots are going to cancel, and I'll just get 2 over 2, and that'll give me 1. So the hypotenuse is always the square root of 2 times the legs. Okay, now I'm going to solve problem 10. This problem is about finding missing angles in triangles, and they give us this hint here about the sum of the angles inside a triangle is always 180. So what am I looking for? I'm looking for alpha, and they tell me this angle A right here is 9 alpha. And so obviously this is a 90-degree angle right there, so I can just use this triangle and the 180-degree rule. So I just got to add all those up and get 180. 9 alpha plus this 90-degree angle right there plus this alpha up there. Those are all the interior angles of that triangle. It's got to add up to 180. That just gives you a simple equation in alpha that you can solve to figure out what alpha is. Okay, here's another one that's just a little bit more complicated. They kind of hide the information a little bit. Let's see if we can get it. So what are we looking for? Find A. So what I'm looking for is A, and they tell me B. B is 40. And they tell me that alpha plus beta is 110. So that whole angle right there is 110 degrees. And I'm looking for A, and this is 90 right there. So first let me just use this triangle and the 180-degree rule and see what I get. A plus that 90 right there plus that alpha up there has got to equal 180. So this simplifies. This means that A plus alpha equals 90. Okay. Now, what else do we know? I can also use this triangle right here and the 180-degree rule. So that means that 40 plus that 90 right there plus beta must be 180. So this actually lets me solve for beta. I'm getting beta equals, so take away 90, that give me 90. Take away 40, that give me 50. I'm getting beta as 50 degrees. Okay, so we're almost there. So they also give us alpha plus beta is 110. So alpha plus beta is 110. So you can just take this 50 right there and plug that in, and that'll let you get alpha. And then once you know that, then you can just take that alpha and plug it in right there, and that'll let you get A. This problem is about a searchlight, and it's rotating around, so you've got some kind of like, I don't know, lighthouse thing? Yeah, I don't know. What does a lighthouse look like? Are they kind of like this? That's my best lighthouse. Okay, and then there's like a light in it, and it's like spinning around. I don't know, whatever. I'm going to use proportionality to solve this problem. The searchlight rotates through one complete revolution every 64 seconds. So I'm going to do degrees per second and set up a proportion to figure out how long it rotates through 90 degrees. So it completes one revolution every 64 seconds. So one complete revolution, that's 360 degrees, every 64 seconds. And that's got, and so now I want to know how long. So that's a number of seconds. So I'll put that X. How long does it take to rotate through 90 degrees? So I named that X. So both of these proportions are degrees per second. Once you set up this proportion, then you can just cross multiply and divide to figure out what the missing seconds is. Problem 17, 15, 16, 17, those are all Pythagorean Theorem problems. I think 17 is the hardest, so I'm going to solve that. So we've got this right triangle. You see this gives a little 90-degree angle down there in the corner, and we're asked to figure out what x is. So I'm just going to plug everything into the Pythagorean theorem. So a squared plus b squared has to equal c squared. Okay. I'll just plug these things into the Pythagorean theorem. Probably the place that most students will get stuck on this is forgetting to FOIL out that polynomial right there, that x plus 2 squared. So let me FOIL that out. Okay, then the square root of 10 squared is just 10. Okay, so now I'm going to collect all like terms. This is a quadratic equation. I'm just going to collect all the like terms and maybe use factoring or the quadratic formula to solve it. So I end up with 2x squared. And then if you minus 10 on both sides, then this will be minus 6. So you could factor it right here, but I noticed that everything is divisible by 2. So I'll just clear that factor of 2 out. Okay, now does this factor? Yes, it does factor. So positive 3 and negative 1. I'm going to multiply those together, and that'll give me negative 3. And when I add them together, that will give me positive 2. So then when I solve each of these factors, I'll get negative 3 and positive 1. And these x's represent lengths of sides of triangles, so it doesn't really make sense for me to have a negative length. So that's an extraneous solution. So x equals 1 is the only solution. Here's a similar problem. They give us kind of an intimidating looking picture, but I actually don't think this is that bad. We're trying to solve for r, and they give us some extra lengths. AB is 2, so just this piece right there is 2. And then AD is 12, so that whole thing along the bottom is 12. So let me just draw this triangle how it actually is. So this is there's 2 here and r there, so that total length is 2 plus r, and then there's r on this side and 12 down here on the bottom. So there's another Pythagorean theorem problem, so I'll just use a squared plus b squared equals c squared. And remember to make sure to FOIL this out, collect like terms, and then you'll probably either be able to use factoring or the quadratic formula to solve it. Problem 19 is about a house. I know it's always scary when you see a picture like that. It's like, oh my God, I don't know anything about houses. I'm not a roofer. Let's try to break it down and see if we can figure out what to do. So the height, they tell us the height is 7.5, and they tell us that whole length right there is 36. And what I'm trying to do is figure out that length along one side of the roof. So if I just draw this triangle out with the information in there, this will be 7.5, and then since the whole length is across the bottom is 36, it's 18 and 18 there. And then this is the thing that we're trying to solve for. So this is just another Pythagorean theorem problem. 18 squared plus 7.5 squared equals x squared. So actually it looks scary, but it is actually kind of not really that bad. For problem 20, they ask us to apply what we learned earlier about special triangles. So we're trying to find the remaining sides of a 30, 60, 90 triangle, and they tell us that the shortest side is 2. Okay, so the hypotenuse is always 2 times the shortest side. Sweet. So the hypotenuse is always 2 times the shortest side. So the hypotenuse will be 4. And then the side opposite the 60 is always, so the other side is always the square root of 3 times the shortest side, and the shortest side is 2, so you get 2 square root of 3. You got to put these answers in with a comma in between them. So you type the first answer in, comma, and then the second answer. Okay, I think the tent problem is probably the hardest problem on the homework. I'm going to try to just jump in here and break it down. They ask us to find how many square feet of material will be needed to make the tent. So really what we're looking for is area. That's our goal here. What is the total area of all of these pieces? So according to the description, this tent is made out of 2 ends. There's a triangle on the front and there's a triangle on the back there. So there's 2 ends. I'll move it down here a little bit. And then there's 2 walls here. And then there's another one on the other side over there. You see? So then 2 walls. And then there's also a floor to this tent, so you don't have to sleep on the ground. Thank you, math problem. I'm much more comfortable sleeping in my imaginary tent now. That was dumb. I'm the worst. This is why people hate math teachers. Stupid stuff like that. Anyways, okay, so let's jump in here. So this triangle right here, that's the hard part. So let's see if we can just work with that triangle that is one of the ends. So what they tell us, So what they tell us is that the height at the center is 3 feet. So that means this is 3. Okay, and this is 60 degrees over there. So I'm going to try to use my 30, 60, 90 triangle knowledge in order to figure out the things that go on the rest of this side. So the basic 30, 60, 90 triangle looks like a square root of 3 over 2, a 1/2, and a 1 there. Okay, so that means that to turn this piece into that piece, I always need to multiply by the square root of 3. So if I put an x down there, what I know is that x times the square root of 3, right? You take the short side, you multiply by the square root of 3, you get the long side. Well, the long leg. So I'm going to take the short side, I'm going to call that x, multiply by the square root of 3, and you got to then get the long side. So I'm just using our knowledge of special triangles to figure out the lengths of these sides. So this means x must be 3 over the square root of 3. Okay, so that's just this one piece right here. So actually the tent, the whole thing, there's 2, right? There's an x there and there's an x there. So if one of them is the square root of 3 and you got to double it, then that whole length over the along the bottom is 6 over the square root of 3. Okay. And also they tell us that the height of this triangle is 3. So remember that the area of a triangle is 1/2 the base times the height. Okay. So this is 1/2. The base is 6 over the square root of 3. And the height is 3. So I'm getting 9 over the square root of 3. So that's just for one of the ends. Yeah, but there's 2 of them. So now to get that total area of this piece and the one in the back there, I need to double this answer. So for both ends, if I double that, I'm going to get 18 over the square root of 3. Okay. Okay, now I need to do the walls of it. So the walls, they go right here, right? So this 6 over square root of 3 is one of the sides of that wall. This piece right here goes right there. So 6 over the square root of 3 there. And they also give me 9 as the length across the bottom. So the area of a rectangle is really easy. It's just length times width. So this is going to be 6 over the square root of 3 times 9. So this is giving me 54 over the square root of 3. But that is just for one of the walls, and there's 2 walls. So in total, I have 108 over the square root of 3 for the 2 walls. Now, what about the floor? So the floor is down here. So remember, this triangle, all the sides of that triangle are all the same. So this is this floor looks like this. Oh, it's actually the same. The floor is the same as the walls. So this is going to be 6 over the square root of 3 right there. And then it's going to be 9 right there. So I get another 54 over the square root of 3 because there's just one floor. So I don't need to double that. So let me just add all these together. And I get 180 over the square root of 3. So this doesn't exactly look like the answer that the book is giving me. Let me just try to rationalize this to check my answer to see if it's the same as the book. So I'm going to multiply by 1 here. I'm going to put a square root of 3 on top and bottom. Then this will now give me 180 over square root of 3 over square root of 3, square root of 3. That's going to cancel. That just gives me 3. And 60 does go in, 3 goes into 80 on 60 times. So I do actually match the answer. I wonder how picky the computer is. I wonder if it would take that answer. Maybe I'll go do the homework and find out.